Well, in this diagram we notice the individual hepatocytes, the individual liver cells just here. Relatively large cells, each with their own nuclei. The hepatocyte is in some ways the functional unit of the liver. The biochemical processing that goes on inside the liver occurs within the individual hepatocytes. But the hepatocytes, as we know, are arranged in these plates. These hepatocellular plates. Now, one of the things that the liver does is it produces bile. The bilirubin will be taken up from the blood side of the hepatocyte, which we'll see again in a minute. And the liver only excretes the bile, or the hepatocytes only excrete bile from one side, from this side of the cell. It's pretty clever, really. They only secrete the bile from one side. And that bile goes into a caniculi, which will drain into a bile duct. Ultimately, of course, going to the right and left hepatic ducts, joining the cystic duct to go into the gallbladder, and eventually on into the duodenum. So we see we have the individual hepatocytes now coloured in, producing bile. The bile will emulsify fats. So it's getting rid of the waste bilirubin from the blood, but it's also emulsifying fats, which is good. Now, the blood supply to the liver is via the hepatic artery and the hepatic portal vein. But here I've just drawn one supplying blood vessel. Here we have a blood vessel. It doesn't matter too much which one it is. It's supplying blood. And it's supplying blood into this vessel here, the liver capillary, which is a sinusoid. So that's the blood going in there, and the blood is going towards the centre from the periphery. So at the corners of these hepatic lobules, for a long time people have described triads. And the triad was a combination of the branch of the hepatic artery, a branch of the hepatic portal vein, but we've only drawn one of them in this diagram. And the third component of the triad was the larger bile duct. But we now know that that was slightly wrong, because there's actually 4 vessels in each corner. We'll see what the fourth one was in a minute. So there's an adjacent sinusoid there, also taking blood towards the central lobular vein, which will drain out from the lobule into progressively larger veins. So the blood supply to the liver, about 30% from the hepatic artery, about 70% from the hepatic portal vein, but both draining into these sinusoids. And we notice that the capillaries in the sinusoid, if I have a different colour for capillaries maybe, just use my pen. Here's the capillary cell walls, the vascular endothelial cell walls. What we notice is there's large gaps between these individual cells with the arrows in here. We say these capillaries are fenestrated, there's large gaps. Now, because there's large gaps between these individual endothelial cells, it means that more can escape from the blood capillaries. So normally in the systemic circulation we would say that the capillaries have relatively small gaps between the individual cells, limiting the amount that can escape. But because there's bigger gaps here, this means that more fluid can escape into this interstitial space. So we notice there's a large interstitial space around the sinusoids. This is called the perisinusoidal space, the space around the sinusoids. So here's tissue fluid forming from the blood, More tissue fluid can form than usual, and some proteins can escape as well. So this intercellular fluid, the fluid between the cells, the intercellular fluid in the perisinusoidal space, is quite abundant. There's a lot of it because there's big gaps, there's big fenestrations. This perisinusoidal space used to be called the space of Dis, or the perisinusoidal space of Dis. And that means that material from the blood comes into contact with the hepatocytes, so material can be taken into the hepatocytes for processing. Once processed, it can leave the hepatocytes and drain. Now, most of the tissue fluid that's formed is going to be reabsorbed. So most of it is actually going to be reabsorbed and flow in this direction, not the direction I've drawn the arrows. The arrows that I originally drawn on this diagram were the flow of the lymphatic fluid. So most of the tissue fluid will be reabsorbed like this, because we know that typically tissue fluid is formed at the arterial end of a capillary and reabsorbed at the venous end of the capillary, and most will be. But there's more tissue fluid not reabsorbed in the liver than any other tissue. And of course this must be drained, and it's drained as lymphatic fluid. So it drains into the lymphatic vessel. That's why there's actually 4 vessels in each corner of the liver lobule. The first vessel is going to be the hepatic artery, the second is going to be the hepatic portal vein, the third is going to be the bile ducts, and the fourth is the lymphatic duct. And actually the liver will produce maybe up to 2 litres of lymphatic fluid per day, about half of the total volume. And to allow material to go in and out of the liver cell, these cells actually have microvilli. So I've drew one here. So if this is the hepatocyte, it's actually this kind of shape. It's got these microvilli to give a large surface area. So this would be the bile side. There'd be another one on that side, producing bile, putting that into the caniculi in the middle, in that direction. Liver cells are two-faced. They've got a bile face, side that faces the bile, and a blood-facing side. But of course we can see that this blood-facing side is actually filled up with the lymphatic fluid, the tissue fluid. It's tissue fluid at this stage, it's interstitial fluid at this stage, in the interstitial space. It only really becomes lymphatic fluid when it enters the lymphatic vessels. So at this stage it's the lymphatic fluid. Material from the lymphatic fluid goes into the hepatocyte for processing through the large surface area and will be exported once it's processed. Any fluid which is not reabsorbed will stay in the interstitial space and will pass in this direction away. So the blood is going from the outside in. Most of the reabsorption is taking place from the outside in, but the small proportion of tissue fluid which is not reabsorbed flows from the inside out towards the lymphatic collecting vessels. So the large tissue space is the perisinusoidal space, or the space of Dis. This means that the liver cells are very well supplied with all of the material which requires biochemical processing and are able to excrete their products. So the functional units of the liver, the hepatocytes, are well supplied with this circulatory system, and the materials that flow in that direction, the bile and the lymphatic fluid, are also able to escape, readily optimizing the conditions for life essential biochemical processes going on inside each of these hepatocytes.